So let's start off today with the problem of the day. Our problem of the day says that a ladder 72 feet long leans against the side of a building, making a 75-degree angle with the ground. How high on the wall is the ladder to the nearest tenth? Okay, if we're going to work this problem, one of the first things that we would want to do is be able to visualize the problem. So we want to draw a picture. So I'm going to draw just a picture, and nothing, it's going to be fancy, it's not drawn to scale, but I'm going to say that this is my ground, and I'm going to say this is the wall of the building right here. So I might denote this as the wall. And I'm going to assume that it makes a right angle with the ground. And I've got a ladder that's leaning up against the wall, and it's doing something like this. So one of the things that I'm told in this particular problem is that the ladder happens to be 32 feet long. So I'm going to label this side of my triangle with 32 feet. I'm also told that the angle makes a 75-degree angle with the ground, and that's between the ladder and the ground. The unknown here is how high on the wall is the ladder to the nearest tenth. So what we're looking for is this distance from here down to the ground. Now what we might do is we could label this as Y, we could label it probably as H since we're looking for the height. And this evolves into a really good trigonometry problem. You notice that with the information that's given, I could not use something like the Pythagorean theorem, which is normally associated with a right triangle, because I don't have the information available to do it. But I do know something about this acute angle right here, and I do know something about this side. Notice that on this triangle right here, this happens to be the hypotenuse of my triangle. Notice that the side that I'm looking for happens to be the side that is opposite that 75-degree angle. Well, most of you out there, if you've learned about trigonometry, have probably heard of something called SOHCAHTOA, okay? SOHCAHTOA. Sometimes you might hear it as saddle our horses, canter away happily to other adventures. And what we're doing here is this is a little way of remembering our trigonometric ratios. What I notice is that for this particular triangle right here, for this angle, I'm looking for the side that is opposite, and I know something about the hypotenuse. So I'm going to be making use of the sine, because the sine of an angle, my sine of 75 degrees, would have to equal the side that is opposite, which I'm going to call H, divided by the hypotenuse, which I'm going to call 32. Now what I'm going to be doing is trying to figure out to the nearest tenth what the height of that is going to actually be. How far up the wall is that ladder? So what I would probably do is see this as a proportion and simply put this over 1 and cross multiply. So I'll get 32 times the sine of 75 degrees, and it's real important that I multiply the 32 times the sine of 75, not 32 times 75, but it's the sine of 75 to get the H value. Now we'll go to our calculator at this point, and with our calculator, the first thing that you'll want to do is check your mode. And you want to make sure that you are in the degree mode in this particular problem. It's not in radians, but it's going to be in degrees because our angle was stated to be 75 degrees. So make sure you're in the degree mode, and I am, so I'm going to second quit, and I'm going to come out of this. And then what I'm going to do on my calculator is I'm going to simply go back and punch in 32 times the sine, and I'm going to hit sine. Notice it opens a parentheses. It's looking for an angle of 75 degrees, and I'm going to close the parentheses, and I'm going to press enter. And the answer I get is 30.9096 and a few more digits out there. The problem asks me to go to the nearest tenth. Well, when I look at the 0.909, to the nearest tenth would just be to the 0.9. So I believe the answer here should be that the height is going to be approximately equal to 30.9, and it would also be in feet. So that's a good problem to help you all review for your ACT, things like this, because trigonometry is always on there. Something else to kind of consider on this problem is that if I had been asked to maybe find the distance that the foot of the ladder was from the wall, I would not have used the sine. I would have used the cosine, because that would have involved the side that is adjacent and the hypotenuse. So whenever you're doing trigonometry, you've got to look very carefully at the triangle that you've been given in the words, and that's why it's important to draw everything out. And then what you want to do is make a decision. Are you going to use the sine? Are you going to use the cosine? Or are you going to possibly use the tangent? and that's a decision that you will have to make based upon the information that's given.